dear students. Welcome to Nuclear Physics Lectures. In today's lectures, we will talk about nuclear fissions or splitting the atoms. So, what is nuclear fissions? Nuclear fissions is the process whereby a nucleus with a high mass number splits into two nuclei which have roughly equal smaller mass numbers. That is, we can define a nuclear process. Just you can see it here in this particular figure. It's a kind of fission reactions in which, according to our definitions, we have a target nucleus, and the target nucleus is split into two smaller nuclei, which we can here see in the form of fission product. I mean, it's a fission product first. This is fission product second, and the mass is closer to 56. Along with that, we have three neutrons, which been emitted in this particular nuclear reactions. Along with that, we have enormous amounts of the energy. I mean, this is one of the particular kind of the nuclear fissions which is being induced by a neutrons from an outer source. Um, so nuclear fissions, there are two basic kind, two basic type of the nuclear fissions that normally we have. The first kind is called the spontaneous fissions, and the second type is called induced fissions. What is spontaneous fissions? Uh, you know that some radioisotopes contain nuclei which are highly unstable and decay spontaneously by splitting into two smaller nuclei. Such a spontaneous decay are accompanied by the release of a neutron. So, what we can say about spontaneous fission and sample wars. And a sample wars, we say that in nature's we have unstable nuclei, and these unstable nuclei decay by itself all after a certain periods of time. This decay or splitting into parts which occur all by itself is called spontaneous fissions. Such reactions don't need any projectile to be hit on, to be bombarded on. I mean, this kind of fissions occur all by itself. That's why we call that spontaneous fission reactions. The second type of the fissions, we call it induced fissions. So in this kind of nuclear fissions, I mean, it's a kind of fissions that is being induced by bombarding the target atoms with the neutrons. I mean, it is a kind of fission that we induce. I mean, it is not occurring all by itself. So at this kind of fissions, we have a nuclei of a particular atoms, and that nuclei will be bombarded by a projectile, and that projectile is mostly a neutrons. And along with that, when we hit that with that particular, I mean projectiles, which is a neutron, so it's split into two equal parts. So, an induced fissions decay are also accompanied by the release of the neutrons. I mean, we utilize neutrons as a trigger. The neutrons we fired on a target nucleus, and once it's split, the nucleus, the target nucleus. So as the results, we not only have the fission product, but also further neutrons are being released as a result of that particular fissions, along with enormous amounts of the energy. So how the fission process occur? I mean, let's have the animations for typical nuclear fissions. Just like, for example, you can see it. I mean, what we describe, you can see it here in animations, that we have a target nucleus that in this particular case is uranium-235. So a neutron, along with that we have a neutron. So what actually we have, a neutrons travel at a higher speed toward a uranium-235 nucleus. Just like you can see it here, it's a target nucleus, and here we have neutrons, and this neutron is traveling toward uranium-235. So what happened? These neutrons it strike the nucleus, uh, which then capture the neutrons. I mean, these neutrons in last slide, just you can see it, it's traveling toward this target nucleus. So what happened? This target nucleus is captured the neutrons. So after capturing the neutron, the nucleus changes. The nucleus changes from being uranium-235 to uranium-236. Why? Because it has captured the neutron. So atomic number has been increased. The atomic mass has been increased by 1. So it's become atomic number 236. Yeah. So that's why we call it uranium-236, because the mass number remains the same. So what happened then? The uranium-236 nucleus form. I mean, once you have the uranium-236 nucleus, so it's very unstable. So what happened with this unstable nucleus? It's transformed into an elongated shape for a short time, just like you can see it here in this particular figure. So what happened then? After that elongated form, it then split into two fission fragments, just like you can see it. The two fission fragments which are being released called barium, so with atomic number 56, and krypton with atomic number 36. And along with that, it's being accompanied by three neutrons. So it's a typical fission process. I mean, you can observe it by yourself that how the fission fragment and the neutrons they are being released in a particular fission reactions. So some of the example of nuclear fissions. I mean, nuclear fissions in the form of equations can be written like this. I mean, we have uranium-235, which is being fired, which is being struck by projectile, which in particularly in this reaction is a neutron. So as a result of these reactions, we have a fissions, and as a fission product, we have bariums plus kryptons, and along with that, uh, three neutrons, and plus we have energy, enormous amount of energy, and we can also have the fissions, the fission with a fission product like cesiums and rubidiums, and along with that, two neutrons. So these are some of the example of nuclear reactions and that we call nuclear fissions. Nuclear fissions can occur in either of these two forms, depending upon the energy of the projectile, depending upon the energy of the target. So I think this all we have for the nuclear fission. So in the next lectures we will come with some more details about nuclear fission reactions. So till then, bye bye.